Reading data from a CSV, loading data in Jupyter Notebook. In this video, we are going to take a look at loading data from a CSV file and the different parameters for effective data loading. For loading data and reading a CSV file, we first need to get our imports out of the way. As usual, we import our pandas. We also import matplotlib so that we can generate some of our first few plots in the Jupyter Notebook. Import done. Reading data from a CSV file. You can read data from a CSV file using the read_CSV function. By default, it assumes that the fields are comma separated. We are going to be looking at some cyclist data from Montreal. We are going to use the 2012 version of it. This dataset is a list of how many people were on 7 different bike paths in Montreal each day. In order to run the read_CSV function, we just need to pass the location of the data as a parameter. I've got the bikes.csv file stored in a folder called data. So I'll just pass that as a parameter and try loading the CSV. Done. Now let's try looking at the first 3 rows of our data. Doesn't look very elegant, does it? You'll notice that this is totally broken. Read_CSV has a bunch of options that will let us fix that though. Here, we'll change the column separator to a semicolon, set the encoding to Latin 1 instead of the default UTF-8, parse the dates in the date column, tell pandas that our dates have the day first instead of the month, and set the index to be the date column. Let's see how our read_CSV function modifies itself to accommodate all these changes. So our fixed data frame is going to be read_CSV. The location is as is. This time we add a separator, which is a semicolon. We specify the encoding as Latin 1 and we specify a list of columns that we want to parse as dates. In this case, we only want to parse the column named date as a date column, and our date format had actually the day first followed by the month. So we specify day first equals true. In order to set the date column as the index of the data frame, we specify the index_call parameter to the name of the column. With those parameters set, we again try and take a look at the first 3 rows of our data. And there you go, a much more aesthetically pleasing and a parsed version of our data set. Selecting a column. When you read a CSV, you get a kind of object called a data frame, which is made up of rows and columns. You get columns out of a data frame the same way you get elements out of a dictionary. Here's an example. Our fixed DF data frame is the data frame that we are using right now, and we wish to extract the very one column out of the data frame. And so we execute this just like accessing a dictionary. And there we have it. The index of the data frame along with the different values of the very one column is displayed as the output. Let's move on towards plotting a column. We just need to add a .plot function to the end, and that's how easy it is. We can see that unsurprisingly, not many people are biking in January, February or March because it is pretty cold out there in Montreal. So we take the data frame, subset the very one column out of it, and put a .plot function above it to generate this plot. And just as easy as it sounded, we have generated our first visualization using the Jupyter Notebook. We can also plot all the other columns just as easily. We'll make it a little bigger too. So you can see it's more squished together, but all the bike paths behave basically the same. If it's a bad day for cyclists, it's a bad day everywhere. So this time we use our plot function and specify the figure size. And there we have it. Notice that since we have specified the date column as our index, the x-axis automatically adapts to that and displays time in the x-axis. Putting it all together, here's the code we needed to draw that graph all together. So we read our CSV files, passing the different parameters already discussed, and then we subset out the berry1 column and use the dot plot function to generate the matplotlib plot. And there we go. You now know how to read a CSV in pandas on a Jupyter notebook.